All right. So let's see. That one was 6. Yeah. So that works. All right. We okay with the first two? Add the radii. Multiply the radii. Add the argument. Divide the radii. Subtract the arguments. All right. In number 3, we're asked to figure out the graphical effect. So if I divided this out in Cartesian, I did a plus bi divided by I, I'd have more of an algebraic effect. It's harder to figure out here graphically what's going on. So what I did is I took it theoretically in polar and called it r cis theta. And when you're dividing by I is that point 0, 1, or the number 1 cis pi over 2. So dividing it out algebraically in polar, we get r cis theta minus pi over 2. So the radius is unchanged, and the argument gets reduced by pi over 2. So graphically, what happens is it takes that polar number, complex number, and rotates it pi over 2 in the clockwise direction. So if you were to answer this on Friday's test, that's what you would say.
So if you show it with like a plus bi divided by I, and then you get like minus ai plus b, and then you show in a graph how that's like a 90-degree
Yeah,
clockwise.
that would work. As long as you can make that.
It makes more sense though the way you did it, so it's probably. What did you do?
Because that would
No.
be b minus ai. I think it is hard to see that that's a 90-degree shift, as long as you can see that. Because it's more. This would be the proving algebraically.
Yeah.
You're interpreting it's just easier to interpret this. All right. Number 4, simplify those two using Demois's theorem from before vacation. What would we get on number 4?
R squared cis 2 theta.
And how was that one?
And r cubed cis 3 theta. Got him. Got him, coach.
All right. So hopefully that's brushed away some of the cobwebs, and we're feeling okay with that. So let's get a little more practice with this. With Demois's theorem.
It's the block.
Little block.
So, what Sean just did there was use Demois's theorem, r to the n, cis n theta. And again, with these, the same thing for the review questions. I'm not asking for your answers in a particular form. So you have to decide whether it's worth to stay in rectangular or to convert to polar. Something like number 1. Since it's to the 4th power, I could square and then square again. Or I could convert and do Demois's theorem. Both sound like 2 steps, it's just a matter of the first way might be a little more tedious. So why don't we get a practice in converting, because that's probably something we also have forgotten.
Yes, sir.
All right, so when I did this with period 4 today, it was like watching a train wreck. The simple things that we forget very easily is to just what triangles we're looking at, how to get the radius, how to get the argument. Very easy to forget that when we've had 2 weeks of fun under our belt. So when you're looking at this, think of it not as a complex number of a plus bi, but sides of a triangle being 1 and 1. That's isosceles, right? So when my sides of the triangle are 1 and 1, back in geometry, what's my radius or my hypotenuse? Root 2, right? So this number in polar would be root 2 cis. Now, again, since it's an isosceles right triangle, I know it's going to be something pi over 4. And since it's negative 1, 1, what would that be?
3 pi over 4.
Those are the type of questions we just have to ask ourselves in progression. What type of triangle is it? If you forget to, but you'll see obviously these are going to get more and more complicated. You don't always have to remember the whole root 2 longer. You can always remember that the radius is the square root of a squared plus b squared. You know, the magnitude of the modulus is just the hypotenuse. So just remember that the b doesn't involve the I. And once we have it in this form, de Moivre's theorem is the easy part. Converting is probably actually by far the hardest. Root 2 to the 4th would just be 4.
Indeed.
And what would my argument be? 3 pi. And then
Reduce pi.
I'm talking about reduced pi.
Reduce it to pi.
Arbitrary.
Because 3 pi.
just in the end, our
Oh,
argument
yeah.
should be between 0 and 2 pi. So if it's negative or if it's too big, just knock it down.
You get that, big boy.
Wait, how come it's not 3 pi? It's just
I like it when you understand
If you were to convert this to rectangular, it would be negative 4 plus 0 I.
Because 3 pi is the same thing as pi.
okay. Yeah, so it doesn't matter, right?
No,
It doesn't
he
matter
he
where.
wants it to be 0 to 2 pi.
What's wrong?
Oh, all right.
With what?
So cosine 3 pi and sine 3 pi is the same as
Yeah.
Put it in a plus bi.
from there.
It doesn't. You weren't asked in either form.
Where?
So if you leave it in that, it's fine. If you call it negative 4 plus 0 I, that's fine as well. Both of them are just as good. Negative 4 plus 0 I. How delightful. Number 2, what are our thoughts on that one?
You can just do that out.
Just do it
Foil,
out.
yeah.
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 There's no reason to convert this to polar and square it. I mean, we'd have to convert, and then we'd have to square it in de Moivre's theorem. But the conversion, I would say, is 2 steps because the radius isn't nice, and the argument's not nice. So we might as well just FOIL this out.
-25 minus 14 I plus 16 I squared.
Figure out what's enough.
You like it when I say it like that? Mega.
Theta?
4 I squared dx. I'll be there for you. This is not a drive-by.
Alright, so let's just FOIL that out, see what we get.
Yeah.
Of course. Wait, so are we gonna be in trouble if we lose one? That'd be pretty well.
9 minus 40i? Yeah, I do that. Okay. Alright, so moving right along, number 3.
Let's foil it.
Math skills.
Alright. In these, we want to be able to see the unit circle. We want to be looking for the radius, the isosceles one. We want to be looking for the 30, 60, 90. And sometimes it's just helpful to rewrite it so that you can see the unit circle there.
No.
And if I factor that 3 out, what does that 3 tell us? It's very helpful.
The radius is 30.
The radius is 3 because it's 3 times the unit circle. So if you can get it into a constant multiple of the unit circle, it just makes your life a lot easier. So then you see that that's R, 3 cis, to the 6th. When my sine is 1/2 and my cosine is √3/2, we know we're dealing with a pi over 6. And it is pi over 6 because both.
Just 3 to the 6.
So now, let's say this was the no calculator section on Friday. Then I would be fine with you leaving it as 3 to the 6th cis. What would my argument be? 5. If it's the calculator section, you might as well throw in 3 to the 6th. But non-calculator, I'm absolutely fine just leaving it like that. Or negative 3 to the 6th plus 0 y. this sitting well with people? Okay enough? Remember doing math? How about number 4? Just in terms of your initial thoughts, look at that. What do we think? Is it rectangular, polar, toss-up?
Polar? Polar?
Uh,
Can you just
toss-up?
modify for the movie CV?
This is one, I want to actually do both ways to see. I mean, when we were just squaring it in number 2,
Oh, that should be.
certainly rectangular was way easier. This one is to the negative second, which means in rectangular we're going to have to rationalize. And it's also not a bad conversion to polar. So for those 2 reasons, I'm thinking it's probably a toss-up. I mean, so
Polar.
let's do this both ways just to see what you would prefer. Let's first just do it out, and then convert.
Low battery.
All right. So if I'm going to FOIL this out under the numerator,
Asking that iPhone charger. Yeah. The wall part of the iPhone charger, but you call it. Yeah, but like, you could really stop something. Have you seen that Vine where he's like, let's check
I get something that looks very simple.
It's just a black guy.
1/50i.
That is very nice.
It is
Very nice indeed.
All right. So then we just have to rationalize it by multiplying it by 1.
I over I.
Yeah. Now, I've heard a couple of. You can multiply by I over because there's no real part of this. It's just 0 plus 50i. We can try and just multiply by I over I, negative I over negative I. The conjugate's not really needed. We don't have to multiply by 50 over 50i over 50i or negative 50 because that seems a little redundant. So let's see what would happen if we just multiply by I over I. We would get negative I over 50. You know, and put it in proper form, 0 minus 1/50th I. That wasn't too bad. Now, let's check the other way. I mean, just in converting, my sides are 5, so my hypotenuse would be 5√2. It would be 5√2 cis, what, 5 pi over 4? We're in quadrant 3. Alright. And we raise that to the negative second, and that would be 25 times 2. So that would be 1/50th. Ah, there we go, we got that part. Cis,
Negative 10.
negative 5 pi over 2,
Oh yeah. I wouldn't do that.
which would be 1/50th cis 3 pi over 2. So I still think it's a toss-up.
Yeah, it's the back.
Maybe the first way would be a little simpler, but it's not a huge example. So look for those things to make those decisions for yourself. You know, is the conversion nice? How high are your powers that you're raising it to? You know, those are the type of things that, you know, this is borderline, that's not, that's kind of borderline. So that's what we're going to have to figure out for ourselves. Number 5 looks like a big one.
Factor out of 9.
Factor out of 9, yeah. See the, similar to the one above it, we've got the multiple of the unit circle. The only thing different about this is that the power is not an integer, but Dumas theorem will work. Isosceles triangle looks to be in quadrant 4.
7 pi over
7 pi over 4.
To the 1/2. Oh, that is nice.
The square root.
Wow.
Yeah. So now we use Demoivre's theorem. 9 to the 1/2 would be.
I love you the more.
I thought you said 12.
Yeah, I thought you said 12. I was like,
The more is he's my boy. He's
See?
my
Yes, this is
hitter, my
Answering a
hitter.
Demoivre's
He's my
question
boy.
in French does make sense.
He's my hitter, my lovely, lovely hitter, my hitter, my hitter.
In French, what would the argument be?
Set, high, still, deuce. No, beat.
Oui, oui.
So you said 12.
Very good, Freddy.
And I didn't say 12.
Yeah, blame me on that.
I said
Alright.
12.
Oui,
Yo
oui.
hablo mucho francés, pero no quiero hablar ahora.
ew. Shut up.
Mi खूप फ्रेंच बोलतो पण आता मला बोलायचं नाही.